Okay, guys, the exercises for this chapter don't look too bad at all. The first thing that I have asked you to prove, I've asked you to prove that, so you need to prove this. This is not the first exercise, but it's the first thing I'm going to discuss. I asked you to prove that if you calculate the vacuum expectation value of any normal ordered operator, you always get 0. You saw this for the Hamiltonian, but I claim it's actually a general rule. And to prove this, all that you have to remember is that in normal ordering, you put the daggers to the left and the undaggered operators to the right. So just remember the definition of normal ordering. And then the other thing that you need to remember is that bra vacuum is annihilated by alpha dagger and ket vacuum is annihilated by alpha. So combining those two facts, the definition of normal ordering and what states the daggered and undaggered operators annihilate, you should be able to prove that the vacuum expectation value of any normal ordered product of operators vanishes. Then the other thing that I've asked you to do is to calculate the normal ordered product of various operators. So I just wanted to do one example with you, and then you'll be fine to do the rest, I'm sure. So let's look at the normal ordered product of phi of x times phi of y. Now, so let's just write out what this is. So the measures we can just write down. There's no operators there, so the normal ordering is not going to affect those. So let's write down the measures. There's two fields. We're going to need two integrals of momenta. So we can have an integral d3k1. This is for the x field. This is over 2 pi cubed to omega k1. Remember, that's the Lorentz invariant measure. Then we've got an integral d3k2. This will be for the second field, the field at y. 2 pi cubed to omega k2. And then we have our fields appearing. So we will have alpha of k1 e to the minus I k1 dot x plus alpha dagger of k1 e to the I k1 dot x. All I'm using here is the mode expansion of the field, and I really would encourage you to memorize that formula. You're going to be using it so much. It is one formula that's worth memorizing and having at your fingertips. Then for the second field, the field at y, we'll have alpha of k2 e to the minus I k2 dot y plus alpha dagger of k2, and we'll have e to the I k2 dot y. Okay, and this is normal ordered. Okay, so what is this equal to? Well, let's just write down the measures again. Good. That's the first measure. Now let's put in the second one. Good. There's the second measure. Okay, so now let's multiply the first terms. But we're multiplying alpha of k1 times alpha of k2. There are only annihilation operators. This obviously is already normal ordered. So we'll just get e to the minus I k1 dot x minus I k2 dot y by multiplying the two exponentials. Then we'll get alpha of k1, alpha of k2, plus, now let's multiply the outer terms. So the alpha of k1 times the alpha dagger of k2. Now, can you see that this comes in the wrong order? Okay, we must have the creation operator first. So we need to write alpha dagger of k2, alpha of k1, then we'll have e to the minus I k1 dot x plus I k2 dot y. So let me just stress this. I'm going to underline this term in red because this term, we actually swapped the order, okay? And that was because we're looking at the normal ordered operator and not the product of the operators. We've chosen a specific ordering. So we need the alpha dagger of K2 times alpha of K1. Then plus, now let's multiply the inner terms. Well, that's alpha dagger of K1 times alpha of K2. Well, that's fine. That's correctly normalized. So we don't need to swap that order at all. We'll have e to the I K1 dot x minus I K2 dot y. And then the final term is an alpha dagger times an alpha dagger. And once again, there's only creation operators. So this is indeed normal ordered. So let's just write down that final term, e to the I K1 dot x plus I K2 dot y. So you can see this is relatively simple to write down normal ordered operators. You just need to make sure that you've written down the operators in the correct order, and it is always creation and then annihilation, okay? And that's precisely what we did to write this down. I think that you will have no problem whatsoever with the remaining exercises. So good luck with those. Let's get cracking with the next chapter.